Okay, so let's start with this. Okay, we'll start with an oxygen molecule here. Yeah, there are two oxygen atoms. There is one here, okay, and there is one here. One is pinned, okay, and we can move another oxygen atom away or close to the other oxygen atom. Now, you can see what happens to the potential energy. So this is potential energy, and this is the distance between the two atoms. Okay. Now we'll see what happens to the potential energy when the atoms come close to each other. Yeah, so we at the starting position, the atoms are much farther away from each other. Okay, and when you bring the atoms close to each other, you can see that at this particular time the potential energy has started to decrease. Okay, it will keep on decreasing. Now it will start to decrease very rapidly. Now you can see that the atoms are very close to each other. At this point the potential energy is the lowest. Okay, if you try to bring the molecules any closer, they will it will increase the potential energy. Okay, so this is the bond length for oxygen molecule. Okay, it's a very short bond. Yeah, we know there is a double bond between two oxygen atoms. It's a short bond, and therefore, so you can see that. So let's start with again the far position, and now in this you can change the forces. Let's talk about component forces. There are attractive forces and there are repulsive forces, and let's see what happens to the forces. Okay, we'll talk about it, Abhishek. Yeah, the question is, why does it increase when we get them more closer? Let's talk about it. Okay, so now we have turned on the forces. Now you should be able to see what's going on with the forces. Okay, yellow is the attractive force and pink is the repulsive force. Okay, and what are the attractive forces? Attractive forces are basically the nucleus of this atom is getting attracted towards, so let's start right here. Yeah, so at this position the nucleus, so you can play and pause, yeah, the animations here. The nucleus of this atom is getting attracted to the electrons of the other atom. Similarly, the nucleus of this atom is getting attracted to the electrons of other atom. Yeah, because the nucleus is positively charged, electrons are negatively charged, and they attract each other. Correct? So this is nucleus electron attractive forces. Yes. So they are strong at this position, and therefore the potential energy starts to drop. So you can see that the yellow arrow is starting to come into play. See that? Yes? You see the yellow arrow? Okay, as you bring them closer, the yellow arrow increases. It becomes larger and larger. Now you can also see that the pink arrow has also started to come up. There is a little pink arrow right there. Can you see it? Okay, now at this point there is a large attractive force and very small repulsive force. Okay, and what are the repulsive forces? The nucleus of each of the atoms are repelling each other because both the nucleuses are positively charged, and positively charged species will repel each other. Okay, similarly the electrons of each atom are negatively charged, and therefore they will repel each other, and so those are the repulsive forces. Okay, and as you bring them closer, you can see that the yellow arrow gets bigger, that is the attractive force gets larger, and so does the repulsive force as you bring them closer. At particular distance here, right about here, even though it's not visible on the screen because the arrows actually goes beyond the screen, but you can imagine that the yellow and the pink arrow should be equal at this point. Correct? they should be of equal distance. The attractive and the repulsive forces are equal. Yeah. Now as you start to bring them any closer, what is now going to happen is the attractive force is going to be weaker. And so now in this one you can't actually see it, but I'll change the atom later and see, we'll see if we can see it on the other atom. But the attractive forces are going to decrease, but you know, as you bring the atoms closer to each other, but the repulsive forces are going to increase much more dramatically at this point, and as a result of that the potential energy increases. Yeah, so at this point, let's say the repulsive force is much stronger than the attractive force, and as a result the potential energy increases. Okay, so you can't have so when you talk about a bond length, okay, so let me start like a bond animation. Okay, so you know, you should be able to see it when you do the demo. You should be able to see that the atom here is actually vibrating. Okay, it's kind of like vibrating back and forth. So you know, the bond length is the average of that length between, you know, so it's kind of increasing and decreasing at a certain point, but it's maximum the bond length is basically the average of the potential energies at that particular instance. Okay, so I don't know if you can see it vibrating over there because of the lag in time, but when you do the demo you should be able to see it. Yeah, let's try and change it with other atoms. Let's say neon. Okay, we start with the same thing. Yeah, yellow is the attractive force, pink is the repulsive force. You start to bring the atom close to each other. Yeah, and you'll see that energy starts to drop. Now here the attractive forces are not as strong. Yeah, and you can see that kind of bumps off. Yeah, that so at this particular point here you can see that the attractive and the repulsive forces have balanced, and that is the bond length for neon. Now here we are not, neon is a gas actually, it exists in elemental state, but at lower temperature it will be a molecule. Yeah, but this would be the bond length of neon, because the attractive and the repulsive forces have balanced each other. If you start to bring them any closer, you can see that the yellow arrow does not increase as much, but the pink arrow, which is the repulsive forces, increase significantly. Yes, okay, so if you leave the atom there, you'll see that basically goes back and forth. The bond kind of, you know, increase and decrease, and that's where that is the actual situation. The molecule does not spend time in a fixed position, it basically is vibrating all the time. Yeah, and so it basically goes back and forth. It spends its time where it has this balanced attractive and repulsive force, and these forces will try to balance each other all the time, and so that's why the molecule vibrates. Okay, is that clear? Yeah, you take another example here, argon. You can see here the dip in the potential energy is slightly larger than neon molecule. Yeah, but the idea is the same, that molecules form bond so that they can have a lower potential energy. Now the potential energy, so you can, this is the potential energy for each atom. Okay, it's higher, it's up here, and this is the potential energy for the molecule. It's lower, and therefore they will form a bond. If you look at the oxygen, the drop in the potential energy is a lot, correct? So the energy is dropping from here to a very low value, and therefore oxygen forms a very strong bond. Okay, so you can see that the molecule is vibrating now since I increase the speed. Maybe I'll leave it there. Yeah, so the drop in the potential energy is big, and therefore the oxygen bond itself is a very strong bond. okay, and therefore oxygen has a larger driving force to actually form a molecule. So oxygen does not exist as oxygen atom itself, it exists as oxygen molecule. Okay, that's the reason why. Yes,